Hello, my name is Roy Tomolino with Beamex. During this short video, I'll show you how to automatically calibrate two different temperature sensors using two separate temperature blocks. Let's take a look at our equipment. First, I've got a Beamex FB660. This temperature block goes from 50 to 660 degrees Celsius. That's 122 to 1220 degrees Fahrenheit. The next block over is the FB150. This goes from minus 25 to 150 degrees Celsius. And the conversion on that is negative 13 to 300 degrees Fahrenheit. I'm also using a Beamex MC6 calibrator. What we're testing is an RTD along with a high accuracy PRT reference sensor. This is increasing our accuracy over the dry block itself by about 10 times. In the high temperature block, we have a thermocouple that we're testing. The calibrator is controlling both of the dry blocks at the same time. You can actually test up to 4 different temperature sensors at the same time using this calibrator. We're using 2. And the way that we're talking is through a USB cable. On the side of the calibrator, we have a USB cable connected to each dry block. Here's what it looks like. So we have the USB converter to serial, which goes to the serial in the front of the dry block itself. So this first USB cable goes here, and the second USB cable goes over here. Let's look at our connections for the temperature probes themselves. We have our thermocouple. In this case, I don't have a thermocouple plug, I have bare wire. On the calibrator, you can connect using a thermocouple plug, or you can use bare wire. If you use bare wire, we have 2 little buttons here. You simply press them down, insert the wire, and let go. And that makes your connection for you. So let me do that. On the RTD side, you may have connections already made, but what I'm using here, I have a 4-wire RTD, and I'm using one of our bare wire connectors. This has a little button here, and this allows you to convert a bare wire to a banana plug. Very convenient. Let me get that plugged back in. So those are all the connections that we have going on here. Let's take a look at our documenting calibrator. On the MC6, we have 2 tests predefined. So let me go to documenting calibrator. Here they are. We've got an RTD, we have a thermocouple. We allow you to group tests together, and we use the term group to do that. So when we hit start, we'll combine both of these tests and run through them all sequentially. So I'll hit the menu button, I'll choose create new, group. I'll pick my first tag in my group. I'll select that I want another one. I'll press that tag. And now my 2 tags are grouped together. The next step is simply to hit this button. Now we can review what we have. Our first test, it says right here, is our RTD. It tells us our position name, it tells us our function name, it tells us our input. And not just the input, but where to connect. If I was new at this, and maybe I didn't know that the RTD needed to be connected right here, it shows me right here on the bottom. For the input, it shows me right here that I need to be connected to my USB port to control the dry block. My input here is 0 to 100 degrees Celsius, and my output is 0 to 100 degrees Celsius. We're actually testing the temperature element. We're proving that at 0 degrees C, it's actually outputting 0 degrees C. Let me go down to the next one. The next test is our thermocouple. Now in the same way, you can see the tag name across the top, and we just called it TC-K to make it obvious. It's a K-type thermocouple. We have our position name, we have our input here. Again, it's telling us we need to hook up to the side USB to connect to the other dry block. And the range is set for 50 to 200 degrees Celsius, and that's for the input and the output. It shows us as well that we're using this set of terminals to measure the thermocouple. Now note, I have a second thermocouple set and a second RTD set that I could use. You could measure 2 thermocouples and 2 different RTDs at the same time. The next step is to hit the check mark. Now once we do this, I've got it set for automatic mode, so I just hit start and wait. It'll do all the work, accept all the points, gather all the data that's necessary. We've just reached the first test point of the first drive block. We're testing our RTD. We have a 15-second delay built in. And you'll notice that we're also on tag number 1 of 2. So what will happen here is it will grab the test point. It's actually just done that. Now it's working on test point number 1 of our second tag using our high temperature dry block. So now we wait for it to hit the temperature. We've just reached our first test point on our thermocouple. You see the countdown, our 15-second dwell time. That point is now accepted, so now we go back to our RTD. So we'll hit our second test point. We've now reached our second test point with our RTD. That's on this dry block here. The 15 seconds have counted down. Now it will go back to the thermocouple for its second point. We've reached the second point of our thermocouple. Once it grabs that value right here, now it'll move to the third point of our RTD right here. We're at our third and final checkpoint for our RTD. One thing you can notice, the dots are all green and they're within these blue lines above and below this 0. Now this will accept this test point soon, and now we'll be going to the third and final test point of our thermocouple. But let me explain something. You can see that on the thermocouple, the lines are actually red, the dots. That means that each test point has failed so far. Now we have the 0, and the blue lines above and below represent our tolerance. As long as the dots are within the blue lines, then we know it's a passing test point. Now we'll wait for the final thermocouple point to heat up. We are coming up on our final point for the thermocouple. We can see that it's actually dropped below the 0, so we have error on all 3 of our test points. Remember, we're doing a grouped calibration. So we're getting the test results from the very first test that we did, which was the RTD from this dry block. Notice on the top it says RTD. So it says passed. It gives us a summary of what the test was, but we can go get further detail. We can enter in notes about the calibration, and this will pop up on the calibration certificate after the fact. We see the graph itself, and we can see the RTD tracked nicely. It was well within our limits, and this would be put back into service with a stamp of approval. And then we have the raw data. Let me save this. We'll save it as found. Check. Now, we have the test for our thermocouple. Notice it says it right across the top, so now we know we're dealing with the thermocouple from the second temperature block. Now this, well, did it pass or did it fail? It's obvious. It says red failed right across the top, and we get an error here of 6 degrees, so that's well outside of our limit. If we look at the graph, we notice that it was high on the low side, and then it was low on the high side. So thermocouples can't be adjusted, so this needs to be replaced. And this is part of the reason that we calibrate. Things drift. We'll save this as found as well. It's an as found failed, and now it's complete. We have our calibration data now. It's stored right in the MC6. We have our 2 tests, the RTD, passed. We have a green check mark next to that. That means that it's been tested and it passed based on our error allowed. The thermocouple has a red X next to it. That means that it was tested as well, but it failed based on our error allowed. The data can be transferred over to another system. You can write it down on a piece of paper, you could type it into another system, or you can automatically upload it into our CMX calibration software for a paperless setup. So we've just finished an automatic calibration of 2 separate temperature elements using an MC6 and 2 different dry blocks with the push of 1 button. Now, you know now that this is automated. You don't have to be standing here watching it. So if you have a scenario to where you have to calibrate 1, 2, 3, or maybe 4 different temperature elements, you can set that up here, push a button, and maybe even leave for the day. Come back in the morning, your data will be captured and stored in the calibrator, waiting for you to grab it. If you'd like more insight on demystifying calibration, check out our other videos. Thanks for watching.